So it's 5:10 and we are about 30 participants. So thank you very much for your time. As the ones that you just joined, I have to have you guys mute and no video. I was planning this like you asked me questions or kind of like guessing what I was trying to say just to see if you get it. But I guess we have the Remind app if you have any questions or any comments or something like that, or the email. And this is being recorded, so it'll be uploaded to the UTSA Prep section year 3. But it just takes like 3 to 5 days in order to get like uploaded and approved, and it's just a long process. But I'll see if I can share the presentation with the ones that weren't able to be here and the ones that were here. That way you have it just in case. So I am Monica Elbjorn. I don't know if you see my video, my little YouTube video, just like kind of like an introduction of me. So I am, I'll be your instructor for this probability and statistics class. So let's just start. So what do we mean by probability and statistics? So what's statistics? Like, it seems like whenever everyone says, oh, statistics, it's kind of like a boring topic, right? It's kind of like, oh, it's a lot of numbers. It's seems very complicated. But really what it is, so this is a statistics. So for me, it's a way to, it's a way to kind of like collect observations or collect some type of data. Have you heard about data? Like, what's data? Well, data is just kind of like observations. Data is real observations. So statistics is a way to collect observations, to analyze them, to summarize them. And then what do you do with that data? You can like interpret, and the most important, you can draw conclusions from that data. So that's the most important part. So you can draw conclusions out of the data. Because if you collect just data, it just doesn't tell you something. Only it's like, oh, okay, that's good that you collected data. But once you're able to interpret it and make a conclusion out of that data, that's what I'm doing. So you see, kind of like have, so these two, so I kind of like just found a tree and just pick some leaves. So these are kind of like very similar size. I kind of like hand pick them. And these are kind of like just random that I picked. So let me explain you why I did this. So does any of these words kind of like relate to you? Like data, sample mean, C-value, rejects per million, population, sample population, PPSS, standard deviation. That seems a lot of concepts. So that's what we're gonna learn today. And hopefully you'll be able to kind of like relate what we're talking about. I don't know how much information you have about this one, but I just wanted to cover like the basics. That way on the future classes, you know what I'm talking about. So when we talk about a population, we talk about like the whole, when we talk about population, the easiest example will be the census. So what we're doing on the census is try to count, we're counting every single people on the United States. So when we talk about population is, we're talking about a group, everything in a group. So the population of our STEM 2020 will be all the students that are on our class. So if we talk about these leaves, my population of the leaves will be the tree, one tree, the tree that I got the leaves from. But if we talk about like a forest that it has a lot of trees, then our population will be all of the trees. So, so for example, if we have a cereal box, our population will be the whole cereal box. And the sample, can you guess? It'll be kind of like if we open it and then we take a couple, that will be kind of like our sample. But if we are in a manufacturing plant and we have hundreds of boxes, that will be the whole population all of the boxes that they produce in a day or in a whole year. And then the sample, if it'll be if we pick like 5 or 10, and then that will be a sample. So that's what I wanted to clarify, that for example, if we have a tree, sorry, can get, if you need to cancel it. Hold on a second. My boss just sent me a message that he wants to get in. Let me get in. So let's see. So what I was explaining is kind of like the population will be the whole tree, and then the sample or the data will be these little leaves. So that's called data, these little leaves that I took. So if we start, so what I tell you about is statistics. So statistics, we collect the data and then we analyze it and then we draw conclusions. And then, so from the samples that we took, that will be observations or data, we analyze it in case we wanna, what about if we wanna do the average of these whole leaves? So it'll be different if I handpick these ones, that they are pretty similar. Imagine this being the census, or if you're doing like a poll, and then you say, okay, let me ask all of my friends what they think about this subject. So it'll be very different if you kind of like handpick your friends to answer your poll, or it'll be very different if you kind of like pick a random person. So we want to use the word random. So for example, on this one, so I kind of like have 10 leaves or 15 leaves, and then I started measuring them. So you can see on the size length that I just put like how many inches, like 2, 2.2, 2. So we start kind of like getting some data that we can work with, or we can tell us something. So for example, here, this will be the mean or the average. I think you're very familiar with like the average. Like if you have your grades and then you get an average, so that's called mean. So if it's from your sample, that will be sample mean. Or if it's from your population, then it's called mu, but I'll go to that later. And then your variables, you see kind of like you have x1, x2, x3, x4. So this is all your sample data. And then if you average those, you get x bar. So your x bar is the average of all your x's. Same with this one. It'll just, the mean will be different because it's kind of like more random. Instead of me handpicking which ones I want, this was kind of like, it has small ones, it has large ones. So this is saying sample mean, but it's just different results. So you can see that the highest is 2.5 and then the lowest is 0.7. So there's a big difference in between these two compared to this ones, that the high was, I cannot see, but it's like 2 and 2.6. So now you know what's a population and then the population mean. Here's where I was saying, like population mean or sample mean. It's very, like you need to know, I guess that's the main thing that I want you to get. That's one of the main things, like I want you to get the difference between a population and the difference between a sample. So the sample, you want to have it random. That way you don't handpick, or you don't manage. You want to have random. That way your results will be more accurate. So population for my leaves will be my tree. So that's my whole population. So for me, it will be really hard to measure every single leaf. So that way we take a sample of the population. So that's statistics. Taking a sample to draw a conclusion. So we can say, okay, the average of the whole leaves is 2.5. And that will be with mostly, for example, for my bossock cereal. So you measure all the colors or all the diameter, and then you will say, okay, out of this population, 10 are, or here you can say, okay, if they are like out of tolerance, then they're rejects or things like that. So now like this data, so these concepts hopefully will be, will get more familiar to you. So we got PP and we got SS. So PP, kind of like guess what it is? Parameters of population. Yeah, we're talking about population. And SS, we're talking about statistics. So we're talking about the statistics of the sample, because it's easier to get a sample and draw a conclusion of the whole population. So the sample will we try to make it random. That way it'll give us enough information so we can draw a conclusion of the full population. There's always, you cannot be 100% accurate. There's kind of like later on, we'll see concept about confidence intervals. We can say we're 95% confidence that the brakes on the car, they won't break, or we are 99% confident that the bag on the car will work. So, or 99.9% confidence, because so kind of like that's why we have samples and population. So again, I just wanted to share like the tree will be my whole population, and then my sample will be these leaves that I got from it. So data. So we do have, guess how many type of data we could have? So we could have two. We could have qualitative data, or we could have quantitative data. So qualitative data is it's kind of like the word quality and versus quantity. So qualitative is non-numerical. So really we cannot quantify it. It's more like another books is called category, and quantitative, it's a numerical. So we can do it, there are numbers. So let me explain you a little bit more. So qualitative data will be kind of like, right now it's afternoon, evening, morning, but it doesn't tell you what will be the difference between the morning and the evening. It doesn't tell you there's no value to it. It's like female or masculine. It can be one category or the other one. What about color? Like on the Fruit Loops, it could be red, it could be yellow, it could be blue, but you cannot say, well, you cannot say the green, you cannot subtract the green from the purple. It's really pink or red or blue. It's good or bad. So, and then quantitative is kind of like numeric. You could have a lot of numbers like time, height, the weather, the length, distance. So quantitative data, you have to use, it's made with instruments such as rulers, a thermometer, some calipers, a scale, so you can measure it. And qualitative, you can sense it with your eyes. You can see the colors. You can see if if a chicken is cooked or raw, or if it smells good, or it smells pretty, or it smells like fresh baked cookies. So, and in quantitative data, we got two types. It could be discrete or it could be continuous. So discrete, they're countable and finite. That means that you can count them. So for example, if you work on a farm and you have chickens, can you have a chicken that put 1.8 eggs? Or let me make you 4.3 eggs. No, it's usually a whole number. So it's a 1 egg, the chicken put 1 egg, or 2 eggs, or 3 or 4. You can count them. And they're finite. That means, let me put an example. Another easy example will be a dice. It has 6 faces. Can it have 7 faces? 8 faces? No, it can only have 6 faces. And then continuous type, well, you can imagine that, well, let me come back to the discrete. So if you have a dice, it has only 6 faces. But what about if you have a dice that it has 6 faces, but in each face, instead of having 1, 2, 3, 4, 5, 6, it has 1.3, 1.4, 1.5. It'll still be the same because it has only 6 faces. You can count the faces. You cannot have 7 faces. You can only have 6 faces. Compared to continuous, they are infinite. They are not countable. It depends on your, like for example, a ruler or the temperature. What is the temperature right now? I don't know what's the temperature in your home, but over here it's starting to get a little bit hot. So probably it's about like 80. Or is it really 80 or is it 81 or 81.1? Or it's between 80 and 81. So you could, it depends if I'm measuring with a digital thermometer, maybe it has 2 digits, like it's 1.11, or maybe I'm measuring the size of the leaf. Maybe I'm measuring with the ruler and it measures 2.3. Maybe it's 2.3, it depends on what are you measuring with. Like what about if you take some calipers, here's a picture of some calipers, and it tells you to the 1,000. So it depends, but there's an infinite number. It can be 0.000000, or it can be 1 point. There's just, so there's no able, you have infinite numbers. So I think you kind of like get the point. We'll see more examples. So what about, I have some examples for you guys, but I guess I'm just gonna answer them all. But if, let's see an example of the NBA, and we're on the playoff, and there's a winner. The Spurs just win the championship. What, that will be quantitative or qualitative? I'm gonna say qualitative because there's only one winner. Are you a winner, or are you the champion, or you're the second place, I guess? But a winner or not a winner? There's no, for example, what about the color of the sky? That will be also qualitative because it's like you have different shade of colors, like dark blue, blue, light blue. So it cannot be like one is replace the other one. There's like, I guess you could, but for now, let's just say like qualitative, just basic on the colors. What about speed limits? Speed limits is quantitative because you could go to 60, 60.5, but your odometer only tells you 65, 66, 67. But if you had like the ones that the police cars had, then those are more accurate, like it will give you. So it depends on your level of measurement, but that's a quantitative one. What about the number of kids in a playground? Quantitative. Number of babies in this picture? Quantitative. But then if you pick the color of the hair, that will be qualitative, like dark, light. So they'll belong to a category. So what about the temperature of, if you're putting a chicken, a burger, a sausage on the barbecue pit? Then that will be quantitative because you're measuring the temperature. Oh, I don't see, you can see this picture, but it's kind of like silver melting. It's another temperature, so it'll be quantitative. If this elliptical will tell you how fast are you running, that'll be quantitative. What about these cookies? So these cookies, I would say it's qualitative, because you could say, okay, this one is with almonds, M&Ms, chocolate. There are different categories, but you could, for example, you could have all the M&Ms and see how many M&Ms, then that will be quantitative. But if you're only measuring the categories, then it will be qualitative. So the data, it will be, how accurate your data will depend on the level of measurement. So how many type of measurements do we have? We have 4. We got nominal, ordinal, ratio, and interval. So nominal is just a category. Let me go to the final one. We're almost done. So you will see we have nominal, ordinal, interval, and ratio. So nominal, it only is the label. So this is nominal. The religion, it's nominal. The race is nominal. Like you could have, it's just a category. It doesn't tell you any number. It doesn't tell you what place is it. It just tells you it doesn't have a zero. There's no number. You cannot subtract. You cannot multiply. So it's just nominal. Ordinal. I like this one. Who likes NASCAR? So if you like NASCAR, if you like Formula One, so so you have a first place, second, and third place. So you got different ordinal, as the word says, is by order, first, second, and third. So this will tell you who is first, who is second, who is third, but it won't tell you for how, like, it was 2 minutes faster. It won't tell you any number. So the difference between the number 1 and 2 is meaningless. Let me see, I got some questions. Yep. Let me just minimize this. Okay. So now we go to, so you can see on this, so we got the nominal, it's only the label, it's only the category. Ordinal, it has the label and it has an order, a meaningful order. And then we got the interval. The interval is, it's order, the difference are meaningful, but it doesn't have a natural zero. That's the most important part, as you can see. Let me go. So it doesn't have a measurable difference. So what do I mean by it doesn't have a natural zero? So for example, what natural zero means, whenever you have a zero, that means you have none. Like, I think I'll give away a quick example for the next one, which is a ratio. But if your bank account, like if your bank account, you have zero, that means you have none money. But for example, what about the temperature? If you have 0 Celsius, that means you have no heat. No, it means like there is some, like if you go to 0 Fahrenheit, is there's a temperature, that means the 0 is part of the numbers. That means by no natural zero. Like there's, like you cannot subtract and get a 0, and that means you have no temperature at all. It's part of the measurements. Let me see if I have another example of that one. So let's go to, let me think about something that has a 0 as an example. Or let's go to ratio. Ratio has everything. Has order, has a meaningful order, has a category, has a measurable difference. For example, age. Age, that means, or age will be an example of interval. Once you have 0, that means it's part of, you have 0 years. But in ratio, you can subtract, like the math is meaningful. So you can subtract, for example, my age 32 minus 20, it gives you like you are 12 over. So it's something meaningful. And that's it, guys. So mainly what I wanted you to take away from this presentation is like there are 2 types. So let's go back. So there's a population, my whole 0, and there's a sample. Like, now I'm gonna make you guys hungry. So my sample will be if I random pick 5. So if I pick the first 5, 0, would that be a random sample? Probably not. I'll have to like, there one from the top, one from the bottom, like really pick a random. So once we got this sample, we could get different type of data. We could see if we could check the colors. That would be discrete data. Let's go to our type of, it could be quantitative, or you could measure, you could sense it, you can smell it and say, this one smells, or you could see the color, or you could use a device like a ruler and start measuring. So that will give you quantitative data. That will give you numbers. that's what we want. And we can have a discrete or we can have continuous type of quantitative. So that's it, guys. If you have any questions, just send it to Remind app. And next time I'm gonna, so this is kind of like a statistics, but next class will be more about probability. What will be the probability of getting a blue Fruit Loops out of 20? Or what will be the probability of, now that we have our sample, like this will be our sample, what will be the probability of getting some colors? So next class will be more about probability, and see you Thursday at 5. Thank you.
Wait.
Okay.
I had opened the chat so that way they can write questions in there if they have some, since I'm not sure if they're talking to each other or not right now, but I opened the chat so that they're able to ask us questions while we're here and while the subject is still fresh on their mind, so that way they don't have to wait for a response, or you don't have to respond to every single person. Are you able to see the chat?
Yes.
Yes. So does anyone have any questions? If so, could you write them in the chat?
And I think it would be better if they could send just the questions through the Remind app. That way I'll get them.
Okay.
And then that way I get them and I'll be able to respond to all of them.
Okay.
Because that was kind of like one of the UTSA requirements, like not.
No chats either?
Right.
Okay.
Sorry, guys.
Okay, well then I guess that's it for today.
Okay, thank you.